quick note before we get into some content. Gotta have one of these messages. Yay. There's been a decent number of students who are posting code on Piazza. Please stop. This is something silly. I feel weird that I even have to mention this. But you can't share code with other students in the class. That's an AI violation that can result in not posting your code to every student in the class, including instructors and TAs. That should be obvious that that's not okay. You can make private posts on Piazza to just the instructors if you need to post code. Don't post your code publicly to the entire class. We have the warning post on Piazza. I'm giving this warning now. If we see that behavior, unfortunately, I'm just going to start handing out Fs for the AI violations. Something I don't want to do, is not fun, but I mean, some students just aren't getting this idea that you can't share your code. I don't know what you're thinking, but just don't. With that, let's get into this. Let's learn about objects and classes. And there's quite a bit of ground we'll cover today. It is a fairly intense lecture. Wednesday was a pretty intense lecture too. A lot was happening. So let's prepare ourselves and get through objects and classes. So the lecture question, what we want to get through today, we want to be able to create a class, be able to create objects using that class as a template, and have that class, instances of this object, be able to count votes. So we want a few methods and some internal state. These methods are going to be able to track some votes, so we can report any number of votes for a particular option that was given in the constructor of the class, where the constructor is given the list of viable options that people can vote for. Somebody votes for something that's not a valid option, that those votes shouldn't count. And also another method that's going to access the state of this object and tell us how many votes were counted for that particular option. And also if the option is not valid, somebody's saying, give me the votes for some option that wasn't given in the constructor, return 0. If you looked at the slides early, I just added that line before the 1 p.m. lecture. So if the option is not valid, return 0 is the defined behavior for that. And then, of course, testing this, write a test suite that's going to test it. Okay, so what is anything that I just said? There were a lot of words in there where if you're not familiar with objects and classes, which you don't have any expectation to be at this point, most of what I just said for the lecture question shouldn't make sense. So let's go through those and talk about what that lecture question is really asking and what we're trying to do, and really fundamentally, what are objects, what are classes, and how are we going to use them in our programs. So objects, we've seen these before. All the code you've written so far is in an object. All the lecture questions are create an object named this with a method named this. We haven't had much state, but what an object is or any state in the required in the questions. But what an object is a container or a block of code that has variables and functions contained in it. Now we've seen objects with functions, and when an object has a function, which isn't really a thing, this is a false thing when an object contains a function. When an object has something that we think of as a function, we call it a method. So objects have methods and variables. The methods we consider to be its behavior. How does this object behave? And the variables we consider to be the state of the object. What state is this object currently in? So we've seen objects with behavior, with just methods. That's what you've written quite a few times already in this course. But we can have objects with state as well. So we can put variables in our objects. If we have variables that are outside of all of the methods, but inside the block for the body, that's going to be part of the state of that object. And that state, these variables are attached to this object. They can change from within the object, and they can change from outside of the object. Any code that has access to this object can change those state variables. They can change these variables. So if we have a method here, it returns nothing, but what it does is accesses the state of the object and modifies that state. So this is what we call a method with side effects. We're calling this for the sole purpose of modifying that state variable, or we're calling it for its side effect of modifying that state variable. Just like we call print line for its side effects, here we have a side effect that's going to modify the state of this object. And we can have methods that will return something and also modify the state. It's also valid. But we have these side effects when the state is being changed. I've mentioned this earlier in class, but it's worth repeating. Var, if we declare a variable of var, that means it is a variable. It can change. The value can change. If we create a variable of val, it means that value cannot change. That variable, that value is always storing the same value, no matter what. If we try to reassign a val, we're going to get an error. And these variables inside the object that are part of the state of the object, I'll usually call these state variables in the class because I want to lead into the state pattern that we'll see later in the semester. But these have many different names. If you've done objects, worked with objects before, you've heard these called probably something else, something many people call them state variables. They're called fields, member variables, instance variables, and there are a variety of other names that these have. We can use these all interchangeably. It just means the variables that are part of the state of an object. I like to call them state variables to make it explicit. They're the state of the object, and then when we talk about state pattern, we should be used to referring to those as the state. Now we can change these if we have some other code with access to our object. That code can access and modify the state variable and access its behavior. So if we have some method that has access to that object, we can call its methods, which might have side effects, and we can access that value, the internal state and the values of that object. So other code can modify this state. Every value in Scala is an object. I'll probably say that a whole bunch of times throughout the semester. So if we have this main, let me just run this. We have our object with state that we saw in the slides. I don't need this so big. So when we access that, internal state variable x was initialized to 10. So if we just access, okay, object with state, x, that's going to be 10. We're going to call double x. That has the side effect of doubling x. Then print object with state.x again. That internal state changed to 20. We actually modified that state from outside of that object. So these can be modified and accessed from other code in our program. And we would do that with imports. We would say import object with state in whatever package. Here, these two files, these two objects are in the same package, so I don't have to have an import. I just have direct access to object with state. This is similar to something we've seen. Math.abs of 6 or math.whatever. Math is an object, and that object has methods inside of it. Now, math doesn't have any state. It's just a collection of methods that we use, that we call to do whatever we want to be able to do. And this is going to be Java, but no, I can't show what I wanted to. Technically, it's going to be a state. But math is an object with a lot of methods. Technically, it's a Java class with static methods. We don't need to get that deep into it. Math, for Scala purposes, is an object with methods that we can call. Same thing we're doing here. We're saying object with state. This is some object that has some state. Unlike math, that can be modified. This is often not something we really want to do, and that's where classes are going to come in. So every value in Scala is an object, so like math dot, we can use that. If we have a string, we can do dot and access its methods. And actually, I wanted to show the string. That's what I was here for, not math. I'm here for string. So like if we go into string, the actual string class in Scala, again, uses the Java string class. Scala doesn't define its own string. It just says, let's use Java string. And the string class, which we'll get to what a class is in a minute, is going to create string objects. And we can see in this class, we have some state variable, which is going to be an array of characters. So I mentioned before that a string, underneath it is an array of characters. Well, here it is explicitly, we have an array of characters. And that's really the one state variable that we're really concerned with. And then we have, let's do starts with this time. Then we have all of our methods that we expect to be in a string. We can look through this class and see all of the, everything that is a string. All the methods are in here. They're just methods that rely on that state. So if we call starts with on a string, we're actually going to, access that, was it called value? Yeah, it must have been. We're actually going to access that underlying character array, iterate over it, and figure out if it starts with that string. So we have state, the character array, and then a lot of methods that are concerned with that character array. They're going to look at that array, that variable with the characters, and read that to be able to figure out what to return from these methods, what to give back to the user. And again, this is Java code, so the order is a little different, but this is the return type. It's going to return a Boolean and say, does that actually start with the input that you gave me or not? It was, I just want to double check. That was named value, right? Yeah, value. So value is that character array. Again, the syntax is a little different because it's Java, but this is an array of characters named value. So, we just saw the string class, but what is a class? All we know are objects, so what are these classes? So we often don't want just an object, like one object with state and methods. Usually we want many objects of the same type. So for example, we don't have just a string object, because then we would only be able to have one string in our entire program. We would say string.value, like what's your value? String.value equals this character array. And then everywhere in our program, every string would have that same value. And it's definitely not what we want. We want to have many, many, many strings in our programs. So what we write and what we have for the string class is a class, which is effectively a template, which is going to be used to create many objects with similar state and behavior, with the same state variables, but with different values, and the same behavior. And that behavior is going to refer to the state of that particular object, or that instance of the class, some terminology that we can use interchangeably, but that object, going to look at that object state and have different behavior based on that. So if I have a string, and I say .length, I want to know the length of that character array for that particular string that I'm working with. I'm not asking the string class anything. I want to know this object of type string, what is its length of its underlying character array. That's what I want to know from that. And then we can have many strings with different values for its character array. And then those methods will look at that particular character array for that. Yeah?
So objects will only have a single state, but the class can have multiple states of an object?
Right. Yeah, so an object, any state variables in an object, there can only be one object of that type. And then whenever we access that one object, it's always going to have the same state across our entire program. If in a file over here, I change the state of this one object that exists, if I say object.state, object with state.x equals 4, anywhere way over here, maybe I have some other code that I want to run, that is going to see that change to 4. With a class, I can create different objects, and I can have different objects in different places in my code, and they can each have their own state. They'll have the same names of their state variables, but they'll store different values. So let's look at a class. We say we have a store that we want to run, and we have different types of items on our shelves. And we want to track each item. Each item is going to have its own description, its own price. And I also want to track how many times each type of item has been purchased. So I don't want just one item. I don't just want to say how many items has this store sold. I want to be able to track each item type. How many of each have I sold and also track the description of price. I don't just want one type of item on my shelves. I want different descriptions, different prices throughout my store. And then I can have different quantities of each item. I have like 20 of them on my shelf. I want to track for that item. How am I doing? How many have I sold? How much profit have I made? Etc. What do I want to do with this? Do I want to put it on sale? Etc. So let's pick this apart. First, this is our first class definition. Instead of object, we're going to use class. And this class is going to be used to create many objects. So we have a class, and most of the definition of the class inside the body is going to look like our object we created. The same syntax, most of the same stuff here. We're going to create some internal state variable that every object of type item is going to have. I'm going to name it times purchase and have it be an int. We're going to have a behavior called purchase. So in our point of sale software, we could have that every time somebody buys this item, call the purchase method, and increment that times purchase, that state variable, by 1. And also an on sale method, which is going to decrease the price by 20%, which is going to modify the price variable, which we'll talk about on the next slide. So most of this is the same as the object. We have variables, one variable here, and methods for the behavior, and we have that defined in the body of the class. Now the new thing is this, what we call the constructor. We use this syntax of when we define a class, give it a name, and then give it a parameter list, which is going to be are the parameters that we have to give when we create a new object of this type. So whenever we create a new item, we want the user to tell us, okay, give us a string for the description of this object you want to create, and tell us the price of it, and then we'll do the rest of the setup from there. So whenever somebody wants a new item, they're going to call this constructor method, which has the name of the class itself, and then, in our case, two parameters for this constructor. This is where our val and var come in. This is a little different than the methods we've seen. If we don't have our val or var here, other objects outside of objects of this type won't have access to these values. So they won't be able to access these variables. If we do val, they will have access, but it of course can't change. In var, everybody has access and they can change that variable. So if you leave off your vals or vars, whatever one you want to choose, just know that you won't have access to those variables after the object is created. You only get one chance to modify them from outside of the class or object. And I think, yeah. These variables in the constructor will become state variables. So you notice I used price down in one of my methods. Once it's in the constructor, that will exist in the object after it's created. So this is the same as saying var price of type double equals, say 0, right underneath times purchase. It will have the same access. So we get a little bit of kind of shorthand with that. If you're familiar with Java or really any object-oriented programming in other languages, you would have to define this several times in the constructor. You'd have to say that this parameter equals the state variable. Scala gives us a little shortcut. If they're in the constructor, they will exist as state variables. And that's what it was. I keep forgetting to mention this. The keyword this, I had it in my bullet points, but I want to make sure I mention it explicitly. The keyword this is going to be a reference to the calling object. That'll make more sense. We'll talk about that more at length. For today, this is going to allow us to access the internal state of the object. It's usually optional. If we just did times purchased here, it would access that state variable, but it's good practice to always include this dot to make it very explicit that you are modifying the state of this object through that method call. So if somebody else is reading your code, it's very clear, this dot, oh, the state is changing, because that can have big implications elsewhere in the code that might, people want to know if that state is changing. Any questions to this point? There's a lot coming at you today. Is there any questions? Anybody just need to take a breather? No questions at all?
I think once I try it, I'll have some.
Okay. So you should have questions about last lecture, right? You had time to try it. Anybody have questions about last lecture? If that's the case? The lecture question last time? Yeah.
So, we're talking about class objects. Are we talking about like hierarchies? How like some are great like the.
Yeah, we will talk about class hierarchy. That's when we get to object-oriented programming, the next learning objective. That's when we have classes inheriting and extending, inheriting from other classes, extending other classes, and the whole type hierarchy. How like everything is of type any in Scala. We'll talk about all that kind of stuff. Like you have Java background, I assume.
No, that's.
Oh, it's weird you had that question. You got that knowledge from somewhere.
Sorry.
Like in Java, everything is an object. For those of you who had that, we'll talk about similar things. There are similar corollaries in Scala. Everything is an any type in Scala. Yes, we will talk about that at length. Any other questions? Yes.
For the last lecture question, does the sequence matter of the final list?
The order of the list? Yeah, absolutely. It was so, and the way we got around that in the example in lecture was to sort both the lists. So then, no matter what the order was, it doesn't matter. So the lecture question itself didn't define the order of the returned factors. So your test has to accept any order with the correct factors. So any order that the factors come in, you have to accept all of them in your testing. And that's a huge question on Piazza. It was asked like 15 times. Is if you sort your test list, the list in your test case, and sort the return value from the factor method, then the order doesn't matter anymore, and you're just checking were the correct factors returned. And I purposely had a strange ordering in my solution to make sure that came out. Or else, if I have them in sorted order and your tests are in sorted order, most people just stumble on the right thing. I want to make sure everybody was looking at that. Yeah, the order mattered. If you sort both lists, your test case and the return value, that was the big thing a lot of students were missing.
So it's supposed to automatically sort them before it even gives you the output. Because I already have an answer, but that's what I'm wondering. Was that how it's supposed
It was so like in the example last time, we would call our anagrams
Yeah, sorry.
and then call dot sorted. I didn't talk about sorting much, but if you call dot sorted, it's going to return a new list in sorted order. But you do that after you get the return value, but before you do the comparison here. And I'm also sorting my test case. If I sort both those lists, now it doesn't matter what order, how I sorted for my test case, how the method sorted, none of that matters anymore. I'm just going to sort them both. So if these are equal, it just means they had all the same values, and that's what I'm after. So it's the same thing with the lecture question. Sort them both, and then the order doesn't matter anymore. And that's just what we have to do when the order is not defined. We got to sort them both, or some other way to get the same functionality. Sorting is usually the easiest. Sort them both, then ask if they're equal. Any other questions? Do you like tripping up students? I don't try to. There's just a lot of content in this course. We got a lot to get through in one semester. All right, so we have our class definition. Now, how do we use this? Great, we have this class. What do we do with it? How are we going to use this? And this is what we'll have to do in the testing for today's lecture question. When you write your test case, you have to create instances of your class, create those objects, and then test those objects. At least one of them. You can get away with just one for this one. My tests only create one for what it's worth. and but create an instance of that vote counter, call the methods, and then check the state. Is everything as we expected in that? And you're doing that just through the two methods for the lecture question, because none of the state is defined. I say it takes a list as a parameter in the constructor. I never say what to call that list. This is, actually I should have mentioned this in the other lecture. If in your testing you're accessing the list from the parameter or any of your state variables, you're going to get errors when you submit to AutoLab, because you have, with high probability anyway, because there's no guarantee that I have the same state variables in my correct and incorrect solutions. And if I do, odds are we named them different things. So in your test, you're trying to access a variable that doesn't exist when I run your test against my code. So in general, when you're testing, only test with things that are clearly defined in the question. Those are the only things you can test. Because the other things, if they're undefined, I probably did something different. Because just the way we name things is probably going to be different. So just be cautious with that. We'll probably still see that question a bit. But it does happen. But if it's not defined in the documentation, you can't rely on it existing in all cases. All right, let's create some objects. So I'm going to create a new, I'm going to use the keyword new to create objects using that class. So class is kind of like a factory that we can use to create a lot of objects of the same type. And what we did was create a brand new type in Scala. That's what types are classes. We created a new class, we just created a new type. So I want a new object of type item. I'm going to use the keyword new and then call the constructor method. The constructor method has the same name as the class. So this can be read as the constructor exactly. This is the name of the constructor method and then the two parameters. I'm going to call that method as the name of the class and then whatever constructor parameters I've defined for that class. So I'm saying, give me a new item, its description is cereal, its price is $3. Now I have an object of type item, new returns that object, and I'm going to store it in a variable named cereal, or a value named cereal of type item. So since I've created a new type, whenever we create a new class, we create a new type, and we can use that type as our variable types, as parameter types. We can have them as return values of methods. We can use these anywhere. We could use things like string or map or int. We can use our type anywhere where we could use those other types. We actually expanded the types of Scala and added one more type named item in this example. So we have a brand new type. I create variables of that type, new objects of that type, and work with that type however I want. And now we can use these variables to access the state and behavior of these new objects we created. We can purchase cereal, put it on sale, purchase it again, and access times purchase. We should have cereal has been purchased 2 times. We can set the state variables directly if they're variables, if they're declared using var. So we want to manually set the price to milk to 1.5. We can do that too. We can call them, use that type as an parameter in a method call, and access its state variables through that variable as the parameter. We can do that too. We can do all of these things and so much more. Not PyCharm. Not this one. And whenever we create, wrong button. And whenever we create a new object of a certain type, that object gets its own copies of each of the state variables defined by the class. So cereal and milk each have the variables description, price, and times purchased. They each have their own copies of those variables. They have the same names, those variables, but they're contained in different objects. So if I say cereal.purchase, that's different than saying milk.purchase. Milk.price, that's going to be different than cereal.price. those are two different variables with the same name, just attached to different objects. So each time we say new class, we're getting new copies of each of those variables associated with that object that was created. So for example, this times purchased. Times purchased, we purchased cereal twice. We didn't purchase milk at all. So when we say times purchased of cereal, we are getting 2. Times purchase of milk, we're getting 0. Each of those objects have a times purchased variable, and those variables are not connected to each other. They are different variables associated with different objects. So we have 2 instances of times purchase, 2 instances of description, 2 instances of price in this code through our 2 objects. We'll talk at length about this one. This will come up a lot next week. Obviously, it's one of the bullet points of the learning objective. Unit testing, of course, we've hammered that down quite a bit so far. The next one is references. We will talk about this at length, and we'll talk about it in conjunction with the 3rd bullet point. We'll start talking about stack and heap memory on Monday. References, let me just give you a quick intro here so we can start thinking about references at this point. So every object you create is going to be passed by reference, and somebody pointed this out. I forgot about the technicality after the last lecture. It's technically passed by values, but the values that are passed are references. So technically passed by value. If you're being that, if you're concerned with that, I'll say passed by reference, but I do mean passed by value, but the value is a reference. So if that matters to you, just know that's the technicality of what's going on. But these will be passed by reference, just like other types. Other types we've had were passed by reference: list, map, and array. And what this means is that a copy is not created when we call a method with these values as the arguments. So when we call a method, there's no copy being made. We are actually giving it the entire object. So when we call, say we have an increased price method that takes one of our types as a parameter, we are actually giving it the entire object. This means that our methods that take a type of our creation as an argument, it can have side effects. So when we create some cereal and call increased price, even though this price increase was reflected, this increasing price by a quarter, was called on this item variable, this item variable was storing the same item that the cereal variable is storing. So when we call this method, we have this implicit line of item of type item equals the argument cereal. When that assignment happens, we're not creating a new item, we're not creating a new object, we're not copying anything. We're actually giving it the entire item of cereal, this item that we created. So when we increase this price by a quarter here, when we assign cereal to a new variable of type item, which is the same thing that's happening, item of type item equals cereal, cereal 2 of type item equals cereal, same assignment, and then increase price of cereal 2. The price of cereal, even though we've never directly increased the price of cereal, that variable, we did, on 2 separate occasions, increase the price of its underlying object, the object that it refers to. So the price of cereal is now $3.50, even though cereal, we never said cereal.price plus equals 25, because we never made a copy of this object. Anywhere where this item, where an item was being modified, it was this item that was created right here. This variable, when it was called here, referred to the same item. Cereal 2, then go into item. That was still the same item because we always just transferred that entire item. We never made a copy of it. This is different from like passing an int to a method. You wouldn't be able to do the same thing with an int, change it, and then have it changed outside of that method call. Yes.
So say you changed say you changed cereal and like you increased the price to $3.25. Could you how would you make a copy of that and not change the original objects?
So if we did want to create an entire copy of that, we would have to say, we would have to create a brand new item, and we would do it, that's not assignment by reference. So we could create a new item and then access the variables of the item that we want to copy. We would have to do something like this if we wanted to create, if we didn't want a copy by reference. We would create a brand new item with those same values. But if we're not using the keyword new, we're not creating a new object. So whenever we want another brand new object with different state variables, we got to use that keyword new. In a few slides, I'll say something that will seem to contradict that, but it doesn't. I'll explain it there. Two kind of one-offs that I want to talk about classes, especially when you're starting the physics engine homework. You're going to run into these. I just want to make sure you know what they are when you come across them. So we haven't seen this yet, but methods can have default values to their parameters. We're using this syntax. If I want to create, we have a 3D vector called physics vector in the physics homework. And in that constructor, we have these equals 0, 0. These are default values so that if we don't have all of the parameters called, say we only give this one value, when we create a new physics vector, -6, the first value, that's going to go to the first parameter, x. So x is -6. And then since we don't have any more arguments, the other two will just default to their default values, in this case 0, 0. If we don't give it any parameters, we'll default to all zeros. Or we can give it all three parameters as arguments and set the entire physics vector. But we can have default values for these. And then any values that you do give it, it just respects the order. If I give it 2 values, I'm setting x and y, and z gets 0. So there's a nice shortcut. Feel free to use that in your code. It's a convenient thing when we don't always want to specify every parameter in the constructor. Sometimes we just want default values. We can also do this in other methods as well. We can have default values with them. And then the toString method, if we, question?
If you like set the last 2 values, it's like you leave the first one to the
No. So good question. Can you set the last 2 values and leave the first one as the default value? No, you can't. You don't have a way to do that. So it will respect the ordering, and that's how it knows which ones to assign. You can't jump around in the ordering. Like for example, Python, you could do something. You could do that. You could do y equals something, z equals something, and let x go to its default. Scala doesn't let us do that. We can only have the default values be the last ones that we don't specify. And the toString, if we want to print our strings in a more meaningful way for physics vectors, I want my vectors to be printed in the standard vector notation in parentheses with x, comma, y, comma, z. So we can do that through a toString. And we'll talk about everything that this means to override specifically. For now, if you have override def toString of return type string equals whatever, that's what's going to be printed to the screen when you call print line, which will implicitly call toString, or whenever you want to convert this value to values of this type to a string, objects of this type to a string. So it's a convenient thing. You'll see that when you're looking through the physics vector code or for the physics engine code, unless you're doing rhyming dictionary. So when you see that, just know, okay, that's how we're getting the vectors printed in this way. So now when you have your test cases, you're testing with vectors and stuff, in your hint text, you want to print out the vectors. Instead of seeing, if you don't have the toString, you'll just see some garbage that doesn't make sense. Now we're going to see vectors in a format that we're used to when we work with vectors. And references, we will talk about references a lot. Here's our quick reminder. You've known about references for a few minutes, so let's remind you about it. if you're doing physics engine specifically, there's a part in physics where you have to remember the previous location of an object as you're updating its location. So you have an object with a location, and it has a velocity and some delta time, and you want to move that object to the new location based on that dt and velocity, but also remember where it came from, where that previous location was at the beginning of that update. So you might be tempted to do what's on the screen here. Previous location equals location. So previous location is going to equal that location, and then update location using your math, using your velocity, using your dt. If you do this though, that assignment was by reference, so your previous location is going to change as you change your current location. So now your current location and previous location are both going to be the new location that you just computed, and you're going to go crazy trying to debug that, trying to figure out what's wrong until you can finally spot that. So here's where you would want to say previous location equals new physics vector of location.x, location.y, location.z. You do want to copy all of those values over to a brand new physics vector. Don't try to reuse that old one. So a bit of warning. Add this warning in the assignment itself. In case you forget, you'll see this again when you get to that part of the assignment. But this will be assignment by reference. This is the slide that's going to seem to contradict what I said. A question?
It's about the work physics in the world.
Yeah.
How much background do you need in physics to like be able to handle math in there? Like,
That's a good question. So the question, how much physics background do you need to do physics engine? I like to argue not a lot, that you could do it with zero, but many students have debated me on that and said, no, you really need some physics. I think you could do it without a lot of physics. You might have to study a little bit of physics on your own for that, to know what a vector is and whatnot. But that's actually the exact reason why there are two homeworks and you have a choice between them. Because I had too many students saying, I've never taken a physics class, I have no idea what's going on, and I'm forcing them to do physics engine. So if you don't know any physics, hop on over to Rhyming Dictionary if you're in that camp. I think you can do physics engine without physics background, but it might take you a little bit. To start thinking in 3D vectors, it does take a little bit of time. So. Do you have physics background?
I'm talking about like high school physics now.
Oh, high school, yes.
Yeah, would that work?
If you have high school physics background, yeah, you'll be fine. Absolutely fine. If you know what a vector is, you'll be fine. Yeah, it's all right. Yeah, I should have asked that before I rambled on. Yeah, no question?
I just wanted to know, so like if you had, like we were talking about the serial earlier, so you have serial 2 that's based on serial 1, changing serial 2 wouldn't change the one it was referenced off of, would
It depends on what example. I had a few different examples I showed. This changing serial 2 does change serial in this example. I went to IntelliJ and showed a different example where serial 2, in this example, changing serial 2 does not change serial because serial 2 is a brand new item. It's a completely different object at this point. In the description and price, a string and an int, those are not passed by reference. We didn't talk about that yet. But those won't pass by reference. So those will not, that's not going to affect us. That's a next week topic. I didn't want to talk about the ints and strings yet, but yeah, those ones, you get a copy of the int when you assign those. Strings are strange the way they work, but you can think of them as the same way that you make a copy of the string. Did I answer your question?
For the most part.
Okay, so I said we have to use new every time we create a new object from a class. It's not always true. For example, we've created new objects of type list. List is a class. We created objects of type list just by saying list and then giving its values. Same with maps, same with arrays. We did this syntax and just created them without the keyword new. We're not going to do this in the class, but there's a special way you can set up your classes to be able to not use the keyword new to be able to create new things like this. It's called companion objects. You would create a companion object, which is an object with the same name as your class, and give it a method named apply, and then in apply you would write your constructor. We're not going to bother with that. If you want to go dive into that, feel free, absolutely. But it's not going to be required content for the course. But just know that list, this is the same as saying like new list will break, it's not the same. But it's similar concept of saying new item. We just don't use the keyword new for these, just because of the way they're set up in the libraries. But in that apply method is going to say new list at some point. There will be, when there is a new list created, there will be that call when this is called. We just don't see it on our end. And I got to talk about this again for those of you with Java background. I know I mention this a lot, but I know in high schools they really hammer on Java because the exam is in Java for high school. So for those of you with Java background, you're probably mad at me by now because I haven't mentioned access modifiers at all, and I had no access modifiers in my code. So I want to explain myself just a little bit, just to make sure that this is explicit and it's out there. So access modifiers control who can access certain parts of your objects, the state and the methods, who's allowed to call them, who's allowed to use that, and even the constructors sometimes. These are controversial. If you're coming from Java, you've probably heard, no, use access modifiers always. But across different communities, especially communities in different languages, across languages, they really don't agree on when and how to use access modifiers. For example, if you've seen Python and JavaScript in 1.15, there's no mention of access modifiers because they don't even exist in those languages. There are no access modifiers in Python or JavaScript. You can kind of simulate access modifiers here in JavaScript, but not really. Everything's public in both of these things. In Java, we have different access modifiers. Private, saying only this object can modify its own state. Public, meaning everybody can. And then protected and package private, which are kind of in between, modifying who can access it. And if you use Java, you've seen lots of code like this, getters, setters, or accessors, or mutators. We won't see these in Scala. You can add this functionality to any state variable with Scala, which is how they get around forcing us to do this all the time. And back to the last question. All right, so have a good weekend. See everybody Monday.